Hello, this is a continuous tutorial from the last one. I'd like to talk a little bit more about Revit inside Rhino inside Revit, just as a way we can fully understand the limitations as well as potential of this wonderful plugin. So first, I have three curves, and then I created a surface. Right? This is something I believe everybody know how to do it in Rhino. So basically, I have this super organic canopy-like surface, right? And this surface, if I load that into my script, as my earlier demonstration showed you, I can create UVs. So basically, I can create, number of points along U and V. Then I can generate curves. And let's just go ahead and hide this original surface so you can see better. So I have curve along U, curve along V. Then I can merge them together. Then I can push this into Revit as a frame structure. To look at this in the top view, you can definitely see these UV lines are kind of, I think these U lines are planar lines. So that means the line is kind of two-dimension, right? But for this side of the curve, this is actually a three-dimension curve. If I look at from the perspective, you can see it's not flat at all. Yeah, another way to describe is you cannot put a plane surface, right, to make the whole curve sit into that two-dimension plane. So this is called three-dimension curve, and this is a two-dimension curve. All right. So bring this into Revit, since I already constructed this as I showed in the last tutorial. You can see the Revit basically just respect, so here I think I have to recompute a little bit in order to make this show up. So recompute. Yeah, sometimes if you did a lot of tweaking, it might not necessarily show the current version. Okay, I definitely see this line all showed up. Well, there's some lines missing. I wonder why. Right. You can definitely see the preview here. There's something wrong. Right, this line is not being loaded. Okay, it might be because they are not two-dimensional. So here, let me just give a curve. I'll put this side in. So this is the two-dimension lines. So if I put it in, right, and here's Revit, and I can see it's updating here. No problem. Right. I see this two-dimension curve has been generated, create a beam system. And if I back to Rhino, if I load the second set, which is a three-dimension curve, I'll just bring that in. Okay, so this three-dimension curve fit into beams. You will see it generates some of these issues, right? Because Revit don't understand this three-dimension beam, so that is a problem. Unless we do something. So I will actually using a command called rebuild. This rebuild curve is actually come from a plugin called pufferfish, right? So here's a P, pufferfish. This is actually pretty cool. You can take, a sequence of curve in, right? It will basically recompute the curve, make it rebuild, and this curve will be cleaned in certain ways. So you can control the degree, you can control the tangent, but in general, by default, if you just rebuild the curve, the three-dimension curve, you can tweak. Well, actually, you cannot. All right. So never mind. This is still not be able to be recognized as a frame system because it's three-dimension. Interesting. Okay, so I will show you another really interesting kind of work out. If I have this curve again, right, and then I load this into contours. Contour is a quick way you can guarantee the line you cut is a 2-dimension. So basically, this direction is organized by x, y, z values. This is vector values. So if I want to go with a 45 degree in a coordination system, so it's x is 1, y is 1, z is 0, right? So it's basically a diagonal line. But if you want to do the other direction, kind of like a mirrored along the y, so you do 1, -1, 0. So by doing so, you can create two sets of curves. If I switch to the top, you'll see they are actually flat curves. Right? This is very important. So when you merge them together, they create this kind of diamond shape. Right? They are 2-dimension curve. So if it is a 2-dimension curve, then you can feed that into the pufferfish to clean up a little bit. Then I can go ahead feed that into Revit. So let's see if Revit is able to compute this set of frame. Okay, so just minimize the window. I do see some error message. It's actually, this part could be really tricky. It doesn't generate anything. All right. So that means we have some limitations. So let me save the file. Yeah, these are 2-dimension. I don't know why Revit don't like it. I mean, theoretically they are flat, right? You can actually compute, a frame system out of it. Yeah, let me just wait a second. All right. Yeah, so for some reason, if I just unplug and replug in, I didn't do anything, just replug in. So now it seems like it's computing. And then let's go back to Revit. Bingo, right? You have this diamond shape for the frame system. All right. So I think this is actually doable. If you do want to, for example, create this diamond shape with Revit beam, you can do it. Okay, and you can see each beam is actually a glue lamp with this dimension 5 by 19. So it's really nice. You can make it happen. All right, so that's how you trick Grasshopper, or just re-drag it in to recompute. Okay, I wonder if I can just try this again. This 3-dimension curve, right? Which is no way you can build it with a frame system. I'll drag it in. Right, now it's working. No, it still got that kind of weird. Oops. Yeah, it still don't like it because it's 3-dimension, I guess. So let me try re-drag in and re-drag in the type. Okay. But again, you see this kind of weird floating frames. Okay, so some of them are actually being generated, but even they are generated, you can see there's no way you can build a frame like this, right? Because the frame is curved and also is bended in a kind of 3-dimension way. You can't really construct a building like this. All right, so I think that is the limitation I want to just show you. If you want to using my script, you have to play with the rules. Ideally, I would just go with a flat curve, called a 2-dimension curve. Either you do that with contour lines, which is guaranteed is a 2D, or you can do the UV. But when you do the UVs, you have to be careful. Right? Yeah, the contour lines works better. See, it's pretty stable. But with UV lines, you can only guarantee, depends on how you constructed the surface. I only see the flat curve along this x-axis, but along the y-axis is a 3-dimension curve, right? So that's the reason it doesn't work. Okay, so this side doesn't work, but this side should work. Yeah, beautifully. Okay, yeah, see the curve now show up. All right, so I'd like to talk a little bit more about this 2-dimension curve and the 3-dimension curve. I call it flat curve or 3D curve. I'm using another example. This is actually a little bit more extreme than the previous one. So this is a model. If I close Grasshopper, this is a model I transferred from another project. This done by a student, and he created this kind of like a dorm with some subtractions. Right? So it's a pretty complicated form. Right? Then I did convert this into a mesh, and then I did the remesh. This is actually a technique in Rhino. You can remesh a geometry. This is actually covered. Just want to show you if you want to see the tutorial is actually posted earlier here. Remesh and the read topology. So basically the idea is if you have an organic 3-dimension form using the remesh, you can change the tessellation. Right? So by this way you can change how the lines kind of flow across the surface. Right? So I don't want to repeat, but one thing I think maybe it's good to show you here is if you imagine these edges will be a frame system, right? This frame, it is actually a 3-dimension curve because it's bended in 3-dimension ways, right? It's not like a contour or UV. So the trick here in Revit, if I do want to construct something like this, it is actually possible. You just need to treat every single edge as a 2D flat frame instead of a continuous frame, right? So it is doable if you know the trick. So here I will show you really quick. Imagine this is the frame system, right? So this frame is already being simplified and remeshed. So the remeshed version is actually respecting the arch in this void space. Right? So if I'm only using this as my example, I will run Grasshopper. So it will take some extra effort. So the first thing I will do is I will load this mesh. So I will just right click, load mesh. Right? Then I will using this function. This is actually called mesh edges. It breaks the mesh into edges. So I have E1, E2, E3. I believe E3 is a naked edge. Well, on that manifold edge, I only have E2, so I have 510 edges come out from this E2, right? Instead of feed that directly into Revit, because you have 500 curves, you want to be super careful. This will crash your computer if you are not careful. So to make things a little bit controllable, let me do this. I will create a new layer here in Rhino called layer 2, and I will just bake this guy into layer 2, okay, just to be safe. Now I can hide the original surface, mesh surface. So you have these edges, right? If I make selection, you have 500 curves. So the point is, can I using these 500 curves to build a frame system in Revit? Right? That will be really interesting. And so the first question is this curve are 2-dimension or 3-dimension? Right? As you can see here, because each one is based on a quads, right? The original tessellated mesh surface. So this is actually straight line, right? It's 2-dimension in this case. So to be careful, I will just build, have this curve. I did this pufferfish remesh, rebuild the curve, then I feed into Revit. So let me just take a small number of curves. I don't want to crash. So set multiple curves. I will just set some curves here. So I have 100 curves selected. Oh, I did hide, sorry. So just right here, set multiple curves. All right, so these 84 curves will be pushed into this rebuild, then push into Revit. As you can see, because it is two-dimension, right? It's a flat, so the Revit is able to understand, but it does have some complaint. Slightly off axis, right? So don't really like it. But anyway, let's go back to Revit and see if Revit is able to construct. Where is it? It's actually here. Yeah, the answer is yes. You got this pretty nice frame system, right? So this is how you cheat the Revit program to do some unconventional frame structure. Is make sure the frame are two-dimension. So let me push this to a little bit extreme. Maybe this is gonna crash the computer, we'll see. I will go ahead just loading the entire 500 curves into this computation. Yeah, so this is actually a double layered dorm system. If I show you the detail, right, you can see there's another layer underneath. Pretty complicated. Yeah, I should do a simpler one, but anyway, I will take this 500 in just to push the limits of Grasshopper and Revit. See if you can handle 500 flat curve in real time. Okay, so this will be a couple of times slower. Yeah, it's definitely froze my computer. All right, cool. It's actually complete the computing. Yeah, so you have these frames generated by Revit, right, using the Revit type. If I check the Revit file, yes, you have this nice, beautiful form completely in Revit. Okay. So if you do want to preserve this for the future, you can actually do here to detach. So when you release the elements, you basically baked these elements from the Grasshopper Rhino into Revit. So now this is independent from the Revit. Okay, so they are still pinged. You can right click, you can unping them, or you can do unping here, right? So you can move them around and you can make duplications. Yeah, I think that's pretty cool. Right. It's getting a little bit slow because I have 500 frames moving at the same time. That's really nice. It's actually, you can move it. Right, that's nice. I'm also able to, since you detached, I'm able to change the dimension. So if you're saying, hey, that's a larger dimension I want to use, I can, select portion of this. I can go with a larger dimension. Another way to do that is you go back to Grasshopper. In Grasshopper, if you want to rebuild, release, you can change the type. So we have the type right here. So that's 5 by 19, but you can do 20 by 40 right here. Okay. Right, yeah. Maybe let's do that. Just want to show the point. Glulam 2040. Okay. I think this will actually recompute everything. Yeah. because I have a large number of lines. Back to Revit. Here I have to do recompute. The line show up. Yeah, I think the connection is broken. I probably have to relink. And save the file. Yep, it doesn't recompute anymore. Interesting. Yep, it might be because it broke the connection. Yep, now it's syncing. But why it doesn't recompute? Let's do recompute. Interesting. All right, yeah, there must be something off. So it doesn't recompute this anymore. But I guess if I just reopen the file and relink the Rhino, everything should be working. Since it's not recomputing, I guess I can just simply select everything. Yeah, then I will just simply change the type here. That should be the same, right? I can change the glue lamp 2040 directly here, so it's gonna compute directly as a native Revit objects. How it will crash, we'll see. Actually, it doesn't crash. That's good. Here we go, bingo, right? We got this super nice frame structure directly computed through Rhino Grasshopper into Revit. Okay, so I guess that's it. This is all I want to cover today, just to talk more in depth about the difference between 2-dimension curve and a 3-dimension curve, and how you can cheat in Revit to make some computing, right, for the sort of like a complicated 3-dimension geometries. All right, so later I will actually post this script online, Roof 2, so you guys could play with it. And here you can see, that is the result of the 3-dimension form using this Revit type 20 by 40. So it's showed up here in Rhino, but here in Revit, I don't know why it doesn't show up, but it's supposed to have some real-time synchronize. It's just some issues. I need to reopen Rhino and recompute. Okay, it's not a big deal. All right, I hope this tutorial will be helpful for you to do some unconventional structures.